Good morning, children. We are going to start with the second chapter, that is solutions. Now, what are solutions? Solutions are homogeneous mixtures. Homogeneous means that the distribution of the two components is uniform. That is, the one which is present in smaller amount, which we call as solute, and the other which is present in larger amount is known as solvent. So the solute is dissolved homogeneously. It means it is uniformly distributed in the solvent. So we call such mixture as homogeneous mixtures. So solutions are homogeneous mixtures. We call them as binary solutions because they are formed by mixing of solute and solvent. We can have different types of solutions, that is, the solute or the solvent can be either in the solid, liquid, or the gas phase. So these are the different components: gas, liquid gas, solid gas. Similarly, gas and liquid, liquid and liquid, solid and liquid, gas solid, liquid solid, or solid solid. So these are different types of solutions in which the two phases, that is the solute and the solvent, are in the different states. Now it is very important that we know the concentration of the solution, because solute, the amount of the solute which is present in a particular amount of the solvent will make a difference. So it is important to know the concentration of solutions. The first method by which we can express the concentration of the solution is mass percentage. Mass percentage means mass of the component in the solution divided by the total mass of the solution. Mass of the component in the solution divided by the total mass of the solution into 100 will be the mass percentage of the component. For example, if you have 10 grams of glucose, 10 grams of glucose is present in, suppose, 100 grams of the solution, then mass percentage of the component will be 10%, because 10 grams upon 100 grams into 100 will be the mass percentage of the particular component in the solution. Then we can have volume percentage. Like we had mass percentage, we can have volume percentage, in which we have to measure with volume of the component. So volume percentage of a component is volume of the component of a particular component. Suppose we have 10 milliliters of a particular component. 10 milliliters of ethanol is present in, suppose, 100 ml of the solution. 100 ml of the solution. Then what is the volume percentage? It is 10%. So this is how you can find out. Then mass by volume percentage also we can find out in a similar manner. If you have one component which is present in grams, and the other, the solution, is in milliliters, then we can calculate volume percentage in a similar manner. Next is parts per million. Parts per million, this is a unit which is used when a solute is present in very small amounts, in trace quantities. If it is present, then we use this parts per million. For example, if we want to find out the amount of a particular gas or a particular inert gas present in the atmosphere, then it is present in trace quantities, so parts per million will be used. Or any pollutant present in the atmosphere or in the water, we use parts per million. Now, what is parts per million? We express it as ppm. It is the number of parts of the component divided by the total number of parts of all components of the solution into 10 to the power 6. A liter of seawater, which weighs 1030 grams, contains about 6 into 10 to the power minus 3 grams of dissolved oxygen. So it is present in very small amount. Then only we can use such a unit, parts per million. The next is mole fraction. Mole fraction is expressed as X. What is mole fraction? If we have to find out the mole fraction of a component, then the number of moles of that particular component upon total number of moles of all the components, that is XA. A is one component, B is another component. XA is equal to Na upon Na plus Nb, where N is the number of moles. Na is the number of moles of component A, Nb is the number of moles of the component B. If we have many such components, then suppose we have to find out the mole fraction of the first component, the next one equals N1 upon N1 plus N2 plus N3, as many number of components there are present. So this is mole fraction, and it is an important unit which we will be considering in this lesson. Then the next is molarity. Molarity, which is commonly used. Molarity is expressed as capital M. It is the number of moles of solute which is present in 1 liter of the solution. So molarity is equal to moles of the solute upon volume of the solution in liters, and it is expressed as capital M. 0.25 m, 1 m of a solution, etc. Molality, another very similar type of measuring unit is molality, and molality is the moles of the solute divided by the moles of the solvent in kg. That is, number of moles of the solute present in 1000 grams of the solvent. That is the difference between molarity and molality. Molality is expressed as small m. Now you can get numericals based on molality, mole fraction, etc. And these are such terms which will be coming quite often later on, and subsequently in other chapters also we will come across them. So these are the units by which we express the concentration of solutions. Thank you so much.